All right, I want to talk about quantum logic and noncommutativity. And I've been studying Basil J. Hiley, his talk on noncommutativity, and there's he makes a comment about the no-go theorem, showing that the classical Poisson bracket doesn't have a symmetric analog, a one-to-one correspondence with the quantum commutator from Heisenberg. And this is due to the uncertainty principle, but it arises out of a deeper non-commutative time and frequency, the nonlocality. So normally this is attributed to the spin. So if you're dealing with 1/2 spin of the fermions, which are like the electrons, then you inherently have this non-commutative or anticommutator that's non-commutative, that doesn't allow a one-to-one correspondence with between the Poisson bracket and the quantum commutator. And so this gives rise to the uncertainty principle. But the issue here is normally this is ignored, because what you do when you're using the Poisson bracket is you're using an average. So the anti-commutator turns out to be like 1/2 of the commutator rule, so you're able to just average it out and just consider that that it's just 1/2 of the commutator, because it cancels itself out, and this is due to the negative frequencies that are canceled out when you square to get the energy for the amplitude and the location of the particle. And so the anti-commutator is also called the Baker bracket, or the Jordan product, and Jordan was the first to develop it, but it's actually also used in Moyle algebra. And so the idea here is to have a quantum algebra that's not it's a non-commutative phase space. And so normally it's considered that you can't use phase space in quantum physics, because the phase space is a classical symmetric space. It's assuming a symmetric geometry. But in quantum physics, you have a discrete quantum measurement that collapses the wave function, and so it's a quantum two-sphere due to the uncertainty principle. Or you can also call it a non-commutative torus, which is the Bloch sphere is a two-sphere as a non-commutative torus or donut. And this is what makes it inherently non-local. So what Basil J. Hiley is saying is that if you use the Moyal algebra, then you're able to actually do quantum physics in a classical phase space, but the Jordan product or the Baker bracket does not reduce to a Poisson bracket or a classical commutation or symmetry, so normally what's happening, what he says that you have to consider the second order of quantization, which would be the Planck's constant squared, and normally this is dismissed again for the same reason, that it's just considered that you can average out the anticommutator. So it wasn't until they included spin as part of a relativistic quantum field theory that then they had to, that Pascual Jordan was corroborated that his inherent noncommutativity was validated. And so the issue here is that when you scale it up, then you still have that non-commutative relation. You can't just, based on the 1/2 spin, you cannot just average it out. And that's what the quantum potential is, as the difference between it's the non-commutative difference between the average of the momentum and the average of the momentum squared, and then the square of the average the momentum squared as a average. It's the I can't remember the difference between the two, but it's but at any rate, so when this is the hidden, they call it a hidden variable, but it's in the mathematics directly. And so normally in quantum logic, this is considered a indeterminate, unknowable, because it's only brought out in the conditional probability. But what Basil J. Hiley is stating is you don't have to use probability, and you don't even have to use a wave function. You're just using the algebra as a process of the future and the past overlapping. And so he's saying that these are like another level of zigzag inside the Feynman paths, the Feynman trajectories. So they're before the level of negative energy that Dirac was talking about, because they're just negative frequency and time reversed signal as non-locality. And so this symmetric bias goes way back in Western civilization. It goes all the way back to the Brahmin code as the basis for phonetic language that's tied to mathematics. And it gets into religion because the Brahmin code mathematics was part of the religious philosophy also. So you define God as I am that I am. It's a tautology that's symmetric. And it's based on the source of the I thought. And so this is the practice in the jnana mind yoga meditation as the vichara, or the repetition of the I thought to listen to the source of the I thought. And what happens is eventually as the left brain gets emptied out, and then you experience light, and then you visualize the source of that light on the right side of the heart. And so there's inherently this asymmetry to the process, the logical process, but that's not focused on in the jnana practice, because the Brahman logic assumed a caste hierarchy system from the Vedic, the chariot Vedic invasion of India around 1800 BCE. And so this I am that I am was directly tied to the Pythagorean theorem used for squaring the circle for chariot wheels. So the I is the height of a triangle, and the am is the base of the triangle, and then the that is this infinite rational convergence to the irrational magnitude, the geometric magnitude. And by having that convergence, then you can claim to have contained time as a visual external measurement. But what's excluded is that there's a eternal rational iteration between the I and the am, and that iteration never stops, and it's because it's driven by this asymmetric time shift. That's complementary opposites. Since it's asymmetric, it can't be contained as a visual measurement in geometry. And this is why you get the non-commutative torus, which is actually the Klein bottle. It inherently cannot be visualized as a closed phase space. So it's an open process of the algebra that's based on this non-commutative time shift. And as Basil J. Haley says, you can choose your own vacuum. And by this, he means the negative frequency and time reverse signal that Alon Khan also talks about. So in the normal sense of the quantum logic, it's normally defined as inherently unknowable and indeterminate. And this is the same as the neither A nor not A. And in the Brahman philosophy, this would be the equivalent of the Buddhist Reformation as a heterodox philosophy, using the neti logic of neither this nor that. So you're never affirming the existence of Atman as the soul, equal with Brahman as God, but rather you're claiming this infinite process of the emptiness that can only be logically inferred. It can never be positively claimed as a contained infinity. The problem with that reform, though, is that it didn't address the complementary opposites that's actually from music theory. And so you have this visual phonetic logic of neither this nor that, but it's still a symmetric visual logic. And so even in the Buddhist culture, you get these mind meditation training. That's the Vipassana tradition in Southeast Asia that was based on the monasteries, and that was tied to the jnana yoga in India. In fact, the what are they called? Not the ashrams, but the Brahmin. They were inspired to have similar kind of monasteries in India based on the Buddhist monasteries. And so even in these early religions, as Achara S. D.M. Murdoch, her book Sons of God, she basically argues the equivalence of the Vedic and the Brahmin and the Christian religions due to the development of patriarchal agriculture is based on seasonality instead of a monthly hunting cycle as the focus of the culture that's matrifocal due to the psychic lunar energy. So you have this solar focus developed from agriculture being tied to seasonality rather than the full moon cycle for hunting. And so this is how it developed worldwide as sort of like a convergent evolutionary development for agriculture from the Holocene geological era developing into the patriarchal Anthropocene era that we're now in, facing biological annihilation. And so it's only by understanding the secret of the negative frequency and time reverse signal in music, through music, that we're able to properly even understand the quantum ontology, as Alon Khan teaches in his Music of Shapes lecture, is that the music theory is actually the simplest example to explain the Heisenberg transition frequencies, where he first developed what was realized to be the non-commutative matrix mathematics it was developed by Pascual Jordan first, but it was Heisenberg's teacher Born who realized it, and then he tried to pass it on to Wolfgang Pauli, and Pauli sort of wrote it off. So then Max Born got Pascual Jordan to figure it out, and he was, I think, 22 years old at the time, but he was, he could do the mathematics. And then, like I said, his mathematics wasn't corroborated until the spin statistics were developed, because even Dirac dismissed it. And so then this Jordan product, as Basil J. Hiley emphasizes, that the Jordan product has been ignored in quantum physics, and the Jordan product is actually the secret of the non-local quantum potential that becomes based on these zigzags as negative frequency and time reverse non-local zigzags in the Feynman trajectories. It becomes the Bohmian trajectory, as the Bohmian momentum. It's not the normal momentum from the wave function as a collapse of the wave function, but rather it's a density matrix, not a probability matrix. And so it's what they call the negaparticle, as with antigravity. So this is like a deep secret, hidden in the quantum physics. And even so, when you look at the discussion around the quantum physics, they say, oh, you can ignore the anticommutator, because you can just average it out into the commutator for the Poisson bracket. But Basil J. Hiley says no, you can't do that. So I'm just going to leave it at that. That Basil J. Hiley, he's challenging the mainstream quantum physicists on a very particular mathematical logic that has physical implications when you're dealing with energy. And he says this is a new quality of energy. It's a non-local anti-gravity energy. Okay, thanks.